Hi there, this is Olivia. So in this video, I want to illustrate an example of how to write proof harness and also function contracts using a classic algorithm binary search. So on top, we have the implementation in Rust. So we're basically given an array and then also a target value. And if the target value is inside this array, we'll return the index of it. And if it's not found, then we return none. So to write a proof harness for it, there's a couple things we need to think about. So first thing is just like unit tests, we want to initialize the variables that are needed to invoke the function. However, different from a unit test, for formal verification, we actually want to initialize them to non-deterministic values so that we can cover all possible cases, all possible inputs. And then the second thing is the precondition. So what must hold true in order for this function to execute properly before calling the function? So that could be constraints and assumptions on the input or other conditions. And then the last thing is after the execution of the function, what must hold true for us to call it that it's correct? So what are the properties or type of results that we're looking for? So feel free to pause the video here, give a thought, and then come back to it. All right, welcome back. So let's break it down step by step. So first of all, for the initialization, we're initializing a fixed size array. However, every single element in the array is a non-deterministic value generated by Kani using the Kani any command. And then for the target as well, we're initializing it to a random value so we can cover both the case where the target is in the array and not in the array. And for the precondition, we're assuming that the array is sorted from smaller value to larger value. And then lastly, for the post condition, we have two types of results we expect. One is that the result is either none, and in this case, we know that the target must not be inside the array. So we need to assert both for this. And then on the opposite, if we do have a valid index being returned, then the value at that index also must matches the target. And that's how we expressed here in the assertion statement. All right, so now that we have all the three filled out, let's try to run it. So to invoke it, we will have Kani and give it the file name and also passing the dash harness flags, tell it what's the entry point, and which is the function here. So if we do this, run this, what we'll see is that we're encountering this infinite kind of unwinding loop. And why that is because in our implementation, we have this while loop. However, for Kani and also its backend CBMC, you couldn't really deduce how many times it would necessarily, how many iterations of loops would it actually go through. So we need to tell it using the annotation of unwind here. So because we're initializing to a size of 5, we just need to always plus 1. So we're using 6 here to tell it that the maximum unwind needed is 6. However, I know that here, because it's login, we don't necessarily iterate 5 times, but this is just to reduce the confusion. All right, so now that we have this, let's rerun the command again. So this time we found out that the verification is successful. So something to verify here is that if we would remove this precondition, which means that the input is potentially unsorted, what should be the expected result? The expected result is that this verification will fail because the assertion will fail because we will not return the right answer in some cases. So here, if we run it again, we can see that they actually did fail. So, which is a good thing to know. And you can also use this to check whether it's either the implementation was incorrect or that the conditions that we specified is either too strict or too loose. All right, now that we have these filled out, let's turn it into a function contract. So function contract is basically expressing the pre and post conditions annotated on top of the function here using the requires and ensures clause. So let me just paste the contract in and we can analyze it. So same thing, assumption, we just turn it into requires, same assumption here. And then for the ensures, this is the same as the assertion back down here. However, we just want to add another syntax, a lambda here. This is just required for every ensures clause. So now that we have this, we can comment out the conditions we have in the harness. And then the other thing we need to do in order to invoke the function contract is to change this annotation from proof to proof or contract here. This is important, otherwise the contracts will be ignored. And the other thing is when we're calling Kani, we need to use this unstable feature here. All right, so now let's run this again. For the function construct, it will just take a couple of seconds longer, but we should be expecting the same result. Yep, so now that we are using function contracts instead of the conditions in the harness. All right, so I have one last thought I want to leave you with is that right now here, what we have verified so far is that for any given array of size 5, that we know that this function is correct. However, we have no guarantee strictly that if it's larger than 5, what would happen? So what if we can write a harness and proof that is unbounded and not limited by a specific size? Let's say we can verify or prove that for the max possible array size given, that those properties still hold true. And so that's the last thing I want to leave you with is exploring the concept of loop contract, because what we're stuck here is this unwind bound because of the loop here. And then what if we can write a loop contract that doesn't necessarily require us to unwind to the maximum possible array size? And then a couple of resources that might be helpful here is the backend CBMC example on loop contract for the same binary search algorithm. And also for Kani, there's the Kani RFC book that discusses this loop contract feature that was recently introduced. All right, I hope this video was helpful and that I'll see you in the future.